All right, so starting with the theory, one of the things that I'm somewhat known for is being a little bit of a stickler in terms of terms. I think that it's helpful for us to be specific about when we use a term, what it means, what it doesn't mean, and the relationships between things. So when talking about systems and distributed systems and applications, first I'm going to start with that position of systems versus applications, because a lot of times we use those terms interchangeably. So starting with the definition of an application. An application is a single executable running on a single machine. All right, so think about your classical Microsoft Word, Microsoft PowerPoint type of thing. Single user running on a single machine. If it has any data, it's storing that data usually onto a local drive. It may be a very complex piece of software. It might have been written by a number of teams over a number of years. Still, for our purposes in this class, we're going to call that thing an application. The main thing about this application is that really isn't aware that much of connectivity. So if we happen to choose a network drive to store our file on, and then that network drive becomes unavailable, it's not PowerPoint's responsibility to figure out what to do about that. It just throws an error up in our face and says, I can't store to that location, give me another location. Now, when we're talking about systems, on the other hand, the situation is slightly different. A system is made up of multiple executable elements, possibly running on more than one machine. So that's the difference between a system and a distributed system. For the most part, what we build today are distributed systems. Even your most trivial web application, by this definition, would be considered a system, because you have the browser as an executable element running on the end user's machine. You have web server software as another executable element running on a different machine. So already you've got two executable elements running on two machines. You throw in a database in there, another executable element running on another machine. And you can see that, again, even the simplest web application is, by our definition, system. Usually has multiple sources of information. The multi-user system is kind of ubiquitous today. And the important thing that we take away from that is a system has to deal with the concept of connectivity, because connectivity is inherent to its structure, all of those executable elements talking to each other. Now, the reason why that's significant is that when we look at each executable element within the system, it does not fall under the definition of application anymore. It has to deal with the concept of connectivity. What is that remote thing that I'm talking to? What do I do when it doesn't respond? What do I do if it takes a long time for it to respond? All of these types of problems are things that don't really exist when you're talking about a single executable application. And that's the point that I want to start our conversation and our whole course with, is that idea of how we program in a remote execution environment differs from how we program in a single executable environment. Because when we look at the common programming models that we're using today, and again, whether we're using an object-oriented programming language like C# or Java, or functional programming languages, or all sorts of hybrids between them, for the most part, the element of communicating with something remotely is kind of, just sort of slap that in there and put some sort of proxy on top of it. For the most part, we've tried to make it look like a remote call is just like a regular call. So you new up some sort of object to a thing, you call some methods on it, you get some responses, and that's part of where the problems of distributed systems start, is trying to abstract away the network. Now, this idea that the network matters, that it's something that you can't really abstract away, not a new idea. It's been around for a very long time. It was formalized roughly 20 years ago-ish by these two fellows, L. Peter Deutsch and James Gosling. Hopefully the name James Gosling rings some kind of bell for you. Father of the Java programming language. For those of you using C#, that definitely qualifies him as an uncle or something, right? The two are similar, or at least were similar when they got started. Now, these two fellows put together a list of common assumptions that people like you and me make when we're designing distributed systems that turn out to be false. and end up causing lots of problems for those systems in production. This list over the years became known as the 8 fallacies of distributed computing. And what we're going to spend the morning on is going through this list, talking through, again, some of the history of that, why we still make these problems today. The interesting thing about a lot of these principles is even though they were penned in a time that was pre-web, and we're building a lot of web-based systems today, that these principles actually still do hold true. And in many ways, actually they're even more painful for us today than they might have been 20 years ago. Because of the size and the scope of the distributed systems that we're building today. So after we go through this list of the 8 fallacies of distributed computing, we're going to add 3 more that a friend of mine, Ted Neward, added in 2006. These fallacies have become known, or this list as a whole, as the 10 fallacies of enterprise computing. You might be saying, how is that possibly 10? It's clearly 11. 8 plus 3 is 11. It's only 10 if you're a programmer and you count from 0, right? So 0 to 10.